Okay, so I shot through a recording of how to make an automatic chicken coop door, and it ended up being super rambly trying to go over a lot of the code I already wrote. So this video is actually going to be about starting from scratch in Visual Studio Code and basically hooking up the automatic chicken coop door and writing all of the stuff that you'll need in terms of code to make all that work. So this was a pretty simple setup that I put together for my girls who are going to get cameoed right here. You can see these simple chickies all gathered up right here. This is the simplest chickie. They can't figure out that the party's inside here. But I wanted to automate them being able to come in and out of the coop without me having to run over there and open it every morning. And that's super straightforward to do using a NodeMCU and a couple other parts. So you can see you can buy this linear, just search linear actuator on Amazon, or you can use the part that's in the link below. Get yourself a linear actuator here. You'll obviously need a Node MCU, which is this guy right here. Motor controller. You can just search 3.3 volt logic motor controller, or again use the link that I put in the bottom. It's up to you. This right here is a fuse for a boat, and it's just connected to a 12 volt lead acid battery. That's a deep cycle battery on the bottom. A little fuse in there. What else we got? And then we've got this, which makes me I kind of liked how I did this, but I got an outlet from like a boat right here and just plugged a smart USB in it to give the power to the Node MCU. So I just run a USB cable from there. So what you're really going to want to hop into is just how to do this in Visual Studio Code and make it look really clean. So I'm just going to go through that step by step. I like to see code written out like that too. If you find it slow, you can just jump around to see how I arrange everything. But I'm just going to hop right in, and we're going to start writing up basically what's called a finite state machine to run our Node MCU here to open and close the door. So let me ditch all this stuff here and get to Visual Studio Code. Okay. All right. So the first thing you're going to do is go down here to your Platform IO add-in and click one of these here. And you're going to start a new project. We're going to call that Chicky Demo. And you pick a board, in this case NodeMCU, this guy right here. Arduino framework is fine, and the location can just be default location. You'll figure out where that's all going. So what it's done is it's made this little workspace here for us called Chicky Demo. In the SRC file, you're going to find your main, and that's going to look just like you would see in the Arduino IDE. So it's going to come with include Arduino, void setup, void loop. And I'm just going to knock these down because I like my little curly cues down there like that. And this is going to be our new friend, this include file. This is where we're going to put header files, and we're going to learn how to make things like this so we don't have to have tons of functions here, and we're going to even make a class today. Or at least try to if I can remember the syntax to it. I might have to cheat and go find it from somewhere else. But let's start by adding the libraries we're going to need. So we're going to need that Wi-Fi manager that we used in the first video. We're going to need Blynk, and we'll figure out what we need as we go along. So if you jump up back to platform home, add your libraries here. So we'll do Blynk, which always for some reason starts with the Wi-Fi manager, which is pretty baller. So we'll click that, add it to the project. Oh, got to pick your project. So it's going to be Chicky Demo. That's added. Let's do another one here. So Blynk again. Add Blynk. Add that to the project. Oh, got to do it again. Chicky Demo. Good to go. All right. So now all those libraries that we probably need are added. We're going to add another file here, and it's going to be called chickycoop.h. This is a header file. So we need if indef. If indef? Is that what it is? Oh, there it is. If indef. This is also why Visual Studio Code is great. The autocomplete is everything here is so much better than the Arduino IDE. You just need to get away from that and start using this. So we're going to do chickycoop underscore h, define chickycoop underscore h, and we're going to camel case that because I'm going to try to do that. Oh, and then once endif. So this is a bunch of preprocessor stuff. I don't really understand it too well, but it makes it work. So I'm no expert, but we're going to be able to include certain things here that we now won't have to include in our main. So for instance, we're going to put the Arduino.h here. We're going to include the Wi-Fi manager. And we're going to include Blynk here. Okay, so now that we've done that, let's save that. When we go back out here, you can now include chickycoop. And what you'll find, this should compile probably, maybe. Please include board-specific header file. Oh, yeah, we'll fix that in a second. So this is going to compile. What they're going to want us to do here, we'll just get it now out of the way. We want Blynk. There we go. We want Blynk simple. That one. Perfect. So now that we include chickycoop, you see we have access to all those libraries that we had before. So we can do a Wi-Fi manager, for instance, whatever you want. Now we don't need all those includes on the top. So everything that's already included here is already, is ready to go. So I'll just recompile that while we don't need to do that right now. But we're going to do another header because now you can see the power of it. So this is going to be super useful for all of our pin definitions. So this will be we'll just call, I don't know, pins.h. And that's going to be the same thing. If and def pins underscore h, define pins underscore h, hashtag endif. And we're going to do define, let's say, open pin, because remember we're making a chicken coop door. We'll just say that's going to be D2. Define close pin D3. So now, same thing's going on here. If we include pins.h, we can now do things like digital write open pin high. So see how convenient that is? Now you don't ever need to remember like, oh, what pin is this? What pin is that? Just define them straight up and just use the open, close, whatever you want to call them. So that's how we're going to set that up. Now we're going to make a class, and we're going to make that class on the chickycoop. And that class is going to be declared by class, and I don't know, we'll give it a really crazy name like chickycoop. And that goes in curly brackets, and gets killed by that, and that should make all the squigglies go away. Perfect. Now you're going to need two things. You have stuff that's public, which means that when we go use it in our main file, the little main file CPP, whatever it is down here, um, you can call it from there, right? So if you go like chicky-coop dot whatever, it'll just show up. Private functions don't do that, and that's where you want to put your meat and potato stuff that kind of makes the sausage, so it looks really pretty from the main file. So we're going to do public functions are going to be, I think, just chicky-coop for the constructor. Yeah, the constructor is what gets called when you. I'll show you what the constructor does later, but just know that that's the first thing that you're going to need. So that's our constructor. We're going to do void run coop, and that's going to take a pointer to the chicky coop. And I'll show you why that's important later, because basically what we're going to do, and now I guess we can do it now because we have enough of that set up. We're going to make a chicky coop. We're going to call it coop. And this is going to be the object that we basically manipulate for the lifetime that the microcontroller is running. So the open state, the closed state, whatever we want to manipulate it on this object right here. But if we pass this to a function and it's not a pointer, that function is just going to work with a copy of it, and it's not going to set anything on what you think it's going to set. So you're just going to need to pass the pointer and then dereference your properties or your function calls to make it work, which is all super simple. There's nothing really to worry about when it comes to that, and I'll show you how to do that. It seems weird, but it's pretty easy to manage when you're when you when you understand the syntax, I guess. So we'll try to cover that here. So we've got run chicky coop, and that's about it. I think all we need. Oh, and we're gonna do a void init coop, and that's it. Oh, and this is gonna be static too. The reason why it's gonna be static is I think we have to pass a static function to the timer. That might not be true. We'll see if that works. We'll get rid of that later. But a static function, since we were just talking about it, is one that doesn't need an instance of a class to be called. So we'll need for our non-static functions, we have to declare this. For static functions, we can just do chicky coop, do static thing or whatever. But I don't think we'll have any examples of that today, but we'll see. So we've got public chicky coop, void init coop, and now we're going to do our private stuff. And our private stuff is going to be void open door. And I guess I'll make privates with the little undercase thing just for the sake of doing that. No arguments there. Void close door. And I guess we'll need some properties. So we'll need a car. Actually, no, I don't think we really need any properties. I think we're good to go. So that's it for the header. See if that compiles and see if we're good to go. Yeah, that's going to compile, no problem. So now that we have all this, we're going to go down to source, new file, and we're going to call it chickycoop.cpp. C++. So do this the same way. We're just going to include chickycoop. And we're going to start making our functions. So the first one that we have is chickycoop. So that's going to be, since it's a function on a class, you do chickycoop, 2 colons, chickycoop. And this is our constructor. It's not going to do anything, but it needs to be here. The next one that we have is, we'll move this up here. And we'll do a init coop. So that's going to be void chicky coop init coop. See, the autocomplete is so nice. So this is where we're going to do our Wi-Fi stuff. Let's see here. So do Wi-Fi stuff, we'll just leave a note for ourselves and then fill all these out and then go back and do it. And then we're going to need static void coop run. So make sure you don't put static again. Put it in the header, but don't put it again here because it'll cause a bunch of problems. So you just do void chicky coop colon run coop. And remember that takes our pointer here. So we're going to be able to run our other functions that are private off of this. So we're going to put our private functions down here. So we've got void chicky coop, and unfortunately autocomplete's not going to show us our private functions, so we've got to do open door. Perfect. I guess it will show us private functions too. And then we're going to do open door stuff. Put this note here, run coop stuff. And then we're going to do down here void chicky coop close door stuff. Alright, I think that we got everything that we're going to need here. We got our constructor, our initialize the coop, which will do our Wi-Fi stuff, run coop, open door, close door. So I gotta go and fetch some of the connecting to Wi-Fi stuff, which is pretty simple. Let me just go pull it real quick. So init coop is just going to do the same stuff that our last thing did. But you know what we're going to do? We're going to make the Wi-Fi manager a public property on the chicky coop so we can manipulate it. So if we want to do that, we just jump back here. We do Wi-Fi manager. We'll call it Wi-Fi, or coop Wi-Fi, we'll just call it. And then we can just go back down here and just do Wi-Fi manager coop Wi-Fi. So now we can just do serial up again. We'll do the 9600 baud rate. Change this guy out for Coop Wi-Fi. Actually, it's got to be the same name that we have up there. So Coop Wi-Fi. Make sure that matches to, yeah, perfect. And this will have to be Coop Wi-Fi as well. And we're going to call this the Coop network. So you guys remember from the last video, this will give you that access point on the NodeMCU that you can connect to using your normal Wi-Fi stuff, which you can go in, put your login credentials, and then your NodeMCU will be connected to the internet that way. So you'll be good to go. So now that we have this coded up, let's go back to our main and just do that for setup. So we do coop.init coop, which takes no arguments. Now our setup, this connects us to internet. And it has no member of init coop, so we're doing a great job. Oh, a nitty coop. There we go. Did I do that twice? I did do it twice. Perfect. That problem has been removed. So that's what's going to connect us to the internet. So while we're here, we're going to need a couple other things to make Blynk run, so we'll just do that here. We're going to get Blynk timer, and Blynk, I think it's just Blynk, right? Oh, I think it's just Blynk. Hold on 1 second. Blynk Wi-Fi? No. We'll come back to this later. But we're going to need a Blynk instance and we're going to need a timer. But we'll worry about that later. So we'll go back here into our run Coop. So one thing that we're going to need that gets rather convoluted is an enumerator for the state. So I don't declare that in the header because I was having problems doing a static cast when I did either a type def or put it there, which is just a way of converting an integer that we're going to get from the Blynk app into a state. So we're just going to worry about that later, and I'll show you how to deal with it. But we're just going to put enumerator state. And we're going to give us a couple states here. And the first one is going to be wait, which is equal to the 0. So whenever we get a 0, it's in wait state. Open door, which is going to be 1. And close door, which is going to equal 2. Knock that off, and then we're good. And then we just got to declare a state, or a state called state. So now we have all that, and now what we can do is we can set up our run Coop functions. So we're going to run the Coop stuff. So we're going to use something called a switch statement. So what the switch statement does is whenever these values are set to wait, it runs everything in that state. So it switches between those states. So we're going to put state here. All states are inside curly brackets. And each one has a case. So we type case. And these things should now pop up in autocomplete. So we'll do case wait, which gets the unusual regular colon. Each state you need a break out of, so you end it with a break. You case door or open door. You just appreciate so much how good this is over the Arduino IDE. And close door break. Okay, so when we open door, we need to run our open door function. So to do that, we take our pointer and we dereference the call here with this little caret looking thing and run open door. And the same thing for closed door. We do Coop, little caret thing, underscore close door. Bada bing, bada boom. So I think, and then I think when we're done running this, we'll come back to it, but I think we have to drop the state out because it might just like run open door forever. So yeah, it'll run open door forever. So when you're done doing that, you have to drop the state back to wait. Oh, and we're going to need a function for whatever that is too. But anyway, and then the state will have to drop back down to wait here as well. So when we open the door, this is pretty straightforward. We just do our standard digital write, open pin, high, and then digital write, close pin underscore low. The reason why it's not auto-completing is we didn't include our pins up here. So now we do that. That shouldn't be a problem. Yeah, there they go. And then this is just going to be the opposite for the closed door. So that's going to be close pin low. And this high. Perfect. And then we're going to need another function here. We'll just call it stop. Stop door. And that's going to be both of these low. We're going to have to go put that in our header. So we'll have a void underscore stop door. And then in the wait, we'll just run Coop stop door. And that is it. So that is going to run on the timer. So when we run our Blynk timer, we're going to load this function in, but we're going to have to do it cleverly because the timer doesn't like things that take arguments. So I'll show you how to get around that later. I don't want to get ahead of myself too much. So I think we got everything that we need here. I think that when we initiate the Coop too, we'll want to do pin mode, uh, open pin, output, and pin mode, close pin, output too, just because that's what we're going to be doing. That'll have to be fixed. Okay, so I think that's it. I think what we just did was we made our two headers, we made our class, that needs to be fixed there, and I think we're good to go. So we have initialized Coop, which sets our pin modes to output, connects us to the internet. Run Coop, which runs the functions as we go through our different states. This is going to be our timer function. Our private function, which opens the door, the one that closes the door, and the one that stops the door. So whenever you're in this state, you open. Whenever you're in this and close, and whenever you're there, you stop. So now we need to be able to set the state. So we're going to need another public function to do that before we finish. So we're going to have void set state. We're going to take an integer as a function. And we're going to get that integer from the Blynk app. But for now, we'll just jump back here. We'll do void set state int state. And our state is going to equal, I think it goes static cast. I gotta look that up. I can't remember. Just a second. So basically what we need to do is it's not gonna like okay, there we go. So it's just gonna be static cast int state. Static cast state dot, and then I think we just do underscore state. I think that's got it. Not quite. I'm gonna have to look that up in a second, I think. One second. I should have been prepared for that. Okay. That should work. Oh, that's what's wrong. That would have worked. But we just have to put that. There we go. So what this is going to do is it's going to cast this integer into the property state. So that basically just lets us set our state from the output of an integer from Blynk. So I think we're done here. Yeah, we're done in here. Sorry for the dead space there when I was talking, but let's see. Yeah, we're done. So let's go here, and now we're going to start doing Coop stuff. So we have set up, we're just going to init Coop. And then I think for Blynk, we need, I know we need a timer, but I think we don't need Blynk Wi-Fi. I think we just need like some other class, and I can't remember what it is. So let me just pull that up here real quick, because it's going to be what do we call Blynk here? I think we actually don't need it. I think it's all static, so I think we're just okay, so we don't need this. But that doesn't sound right, actually. One second. Boy. I guess so. Yeah, we'll give it a shot and just see what happens. So then we'll just do Blynk dot config. Yeah, we don't need it. So remember, because we're connecting, not using Blynk, because our Wi-Fi is like for humans and not some weird robot thing that it doesn't understand, we're going to use blink.config, not blink.connect or whatever it is. So you put your auth code from Blynk in here, and you're good to go. And then you do timer.set interval, and that's going to be timer will call f every milliseconds forever. So every 100 milliseconds, it's got to be a long. We have to call our Coop function, but we can't pass a function that takes an argument here. So we need something called a wrapper. So we're going to call this Coop wrapper, and we're going to do. Oh yeah, we did need it as a static function because we have to pass it for the Coop. So we did that right. See here where we declared it static? This is exactly correct. So we do Coop, or we do Chicky Coop, run Coop, and we pass. This is how we get the pointer for this. We put the and there, pass the Coop there. Perfect. So our Coop wrapper is what we pass here. And now we've set the interval timer exactly how we need. Perfect. That's excellent. So in our loop, we do blink.run, timer.run. I didn't like that. It's got to be under case run. So run. Okay. So that's all we need for the loop. Now we just need to have a way for the virtual pins that we're using to send us the states that we need. So to do that, we just use blink right. So this, we'll just do V0. Let's say we set up the virtual. Let's say we've got the Blynk app going, we set it up, and we assign virtual pin 0 to the open button. Well, we want it to send, when the button is depressed, the number 1, and when the button is not depressed, a 0. So you know where it has like the 0 and it steps up to the 1, you put a 0 here and a 1 here. So when you push that button, it just keeps sending this here. So what we're going to do is we're going to do Coop dot set state param dot as int. Can't remember what goes in there exactly. I think we need the Blynk output though. So it's I have to look that up real quick. It might just be param as int. I'm pretty sure it is actually param as int. Yeah, that's it. What didn't it like here? So let's just see if all that compiles. Coop wrapper was not declared in scope. It just wants. So you just have to go up here and just do void Coop wrapper because it's goofy. It should fix it. If not, we just move this up here because it's just going to have a connection. And then it says undefined reference. Okay, let's look through this real quick here. Multiple definition of Blynk. So we have Chicky Coop, which includes there. Undefined reference to set state. So let's just make sure that we did this right. We have void set state int. And then, oh, yep, there we go. It just wants us to do chicky coop. There you go. And then that should unfurl itself. And then while it's doing that, we'll just do what our clothespin would do would just be the same thing. So let's say, here we define that it closes on, what do we have? It closes on 2, so your button will go from 0 to 2 in this case, because you still want to drop back to wait. So we just need to sort out why we have multiple definitions of Blynk. And that's going to be, we declare chicky coop here. So this should be pretty simple to fix. We're just going to chicky coop, pull that out, put it there, and it should just stop having a nightmare. There you go. Whatever, right? Whatever makes it work. So that's it. We put together a class to run our chicky coop, a finite state machine to run our chicky coop, and we did it all using the power of Visual Studio Code, which is so much better than the Arduino IDE. So I'm going to upload all these as an example to the Git. You can find that in the link below. Copy and paste everything to your delight. All this should open and close the chicky coop door. Remember a couple things. When you set it up, your button for your close, needs to jump up to whatever you set that close definition to. So you want to set that virtual pin to 2 if it's 2, 3 if it's 3, whatever. Make sure they all drop back down to your wait when they're not pushed. Aside from that, that's it. So I hope you have a lot of fun. This was a lot of fun to make. And let me know if you have any questions. Leave them in the comments. I super appreciate it. Thank you so much.